Hi everyone, Professor Christina Sober from Cal State Long Beach speaking here. And in this video, we're going to talk about probability and odds and how to write odds and how to convert odds and probability to one another and what the differences and subtleties are between probability and odds. We're going to do it with examples. So what probability statement says the same thing as the odds for the mammoths winning are 3 to 10? Well, first, I think it's helpful to write, how do I write odds properly? So 3 to 10 is the same as 3 colon 10. Either notation is fine. The odds for the mammoths winning are 3 to 10. What's cool about odds is whatever they say first goes first. So winning is the first thing they're mentioning compared to, well, the opposite of winning, of course, is not winning. I know we in English and in language have a different term for the opposite of winning is losing, but for odds, you really just want to write what it is and what it is not. But if you want to write losing instead, that's fine. No harm, no foul. But this is how odds work out. Odds compares the number of times something will happen compared to the number of times something will not happen, or depending on the context, the opposite. And so let me write that down. Odds compares uh, the term is favorable outcomes to not favorable outcomes. And when they say the phrase favorable outcomes, they mean what they're saying first. Um, it's little funky things like that, but the two still works out. Two is the thing on the left, and was the favorable outcomes, and two, the thing on the right is the not favorable outcomes. So we have winning to not winning. When we're talking about probability of winning, let's say, we talked about this before. That's the number of times you have winning over the total sample space. Well, in a sample space, thinking about winning and not winning, in probability world, for this odds comparison, all you have is winning and not winning. They don't care about losing or tying. All they're saying is, did you win or did you not win? So for a sample space, we're doing odds of winning is what we want to have happen. The sample space is actually winning or not winning. All of those outcomes. So we win 3 times and everything else, well, winning is 3 or means to add and not winning is 10. Let me highlight for clarity. Winning is 3 compared to not winning is 10. So the probability, which says the same thing as 3 to 10 for winning, is 3 over 13. Writing a little subtlety here. The odds 3 to 10 is the same as, but AKA, it's also known as the probability of 3/13. The 13 comes from 3 plus 10. We have a statement here on the left-hand side of the screen. Let me shrink it down just ever so slightly so I have a little bit more space. Odds compares favorable outcomes, favorable outcomes to not favorable outcomes. Probability compares or considers or looks at favorable outcomes out of all possible outcomes. I hope the way I wrote this is a little bit more clear. I'm trying to make it look like a fraction bar going on here. Favorable outcomes is your numerator. All possible outcomes is the denominator. Let's look at another example. I think it'll help out. What probability statement says the same thing as the odds for dinosaurs losing are 6.7 to 1? Let's write the odds statement first. Well, I know it's going to be 6.7 to 1, like this. But wait a second. That decimal looks kind of funky. And it is. Odds looks just at favorable outcomes to not favorable outcomes. Well, an outcome is something that is possible to have happen. Can something happen 6.7 times? No, it either happens entirely or doesn't happen entirely. It can't partially happen. So, when we're doing odds, we only want whole numbers. Right now, we have 6.7 being compared to 1.0. What am I going to do? I'm going to multiply both sides of this odds by 10 so that that factor shifts the decimal place over 1. And now I have 67 to 10 because odds should be whole numbers. Now for this case, losing was said first, so losing goes on the left and not losing goes on the right. All right, to be realistic to what we say, this is losing compared to winning. Though, tying could happen, but win or lose is what we'll look at. The probability looks at favorable outcomes over all possible outcomes. We're doing probability of losing. Losing happens 67 times, and all favorable outcomes, or all possible outcomes, there's 67 of losing, and then there's 10 for not losing. We get 67 over 77. So the probability of losing 67 over 77 is the same as the odds of losing 67 to 10. There's some subtlety here between odds and probability. If you still have questions, please reach out. I am happy to help in any way possible. Thanks so much for watching. Talk to you soon.